Okay, there. So solve the quadratic inequality x plus 2 times 1 minus x is greater than 0. So for this one, let me show you how to construct a sign chart. Okay, there are basically 3 steps to constructing the sign chart. First, you have to determine the critical numbers. What are the critical numbers? They are the numbers or the values of x in the domain of f that make the function either 0 in value or undefined. Now, by the way, in the syllabus, or sorry, in the modules, you can read about the solutions of the problems discussed in class. So I also use the modules to create a PowerPoint presentation for our synchronous sessions. So if you don't understand any particular part of the solution, then you may consult the handouts. Okay, the explanation is more detailed there. So I assume that you have read already the module before we have the synchronous sessions. So anyway, there in the handouts, you have the definition of critical numbers. But again, they are the values of x where the function is either 0 or not defined. In other words, you just have to equate the factors present in the expression or in the function to 0. So that includes the numerator as well as the denominator. Once you have found the critical numbers, you plot them on the real line. So for this one, there are 2 critical numbers. You equate the 2 factors to 0, you get -2 and 1 as critical numbers. Then you plot those 2 numbers on the real line and observe that they will divide the real line into several sub-intervals, as I will show. Now, once you have constructed the real line or plotted the critical numbers on the real line, then you pick a test number for each sub-interval. And you will be plugging in those test numbers into the given function there in the inequality. Now, I've already given you the sign chart here. So let me just explain how I got the sign chart. So again, here's our inequality. We want to solve this. So once again, get the critical numbers. You equate the 2 factors to 0. So we have -2 here and 1 here. So there will be 3 sub-intervals. -infinity to -2, -2, 1, 1 to infinity. So how do we determine the signs at each sub-interval? Now, the sign at each sub-interval will be unique. So what does that mean? If the sign is unique, we just need one test number to determine the sign. So for example, let's take -infinity to -2. There, you see that the sign is negative. How did I come up with that? Well, I picked a test number. Preferably, okay, when you pick a test number, choose one that is a whole number and close to the end point or endpoints. So in this case, you can choose -3. So what do you do with that test number? You plug it into the function here, x plus 2 times 1 minus x. That means you will be replacing x by the chosen test number. So here it is. -3 plus 2, 1 minus -3. Plug in. That's equal to -4. However, since you only need the sign, you don't need really to give the exact numerical value. So you just have to know the sign for each factor. So this will be positive, and this will be, this will be negative, and this will be positive. So a negative times a positive is a negative. So we have a negative for the subinterval here. So put a minus sign on top of that subinterval. So you do the same for the other subintervals. So let's show again. For the middle interval, pick any number, preferably a whole number. Now, if there's no whole number, then pick a very convenient fractional number. You can use your calculator, by the way. So the most convenient one to use is 0. So plug in 0 into the function again. You have it here. It will be positive times positive. So it will be positive. So we put a positive sign on top. So it's positive on the entire interval there. By the way, you pick any other number, you will always get a positive result. It's impossible to get a negative result. That's why we only need one test number. And finally, for the interval 1, infinity, pick a test number again. 2 is here. Be sure it's there. Sometimes students get confused or they get careless. So they plug in a test number that's not really there, especially when you have the endpoints as negative numbers. So be careful. So plugging into, we have the computation here. So it will be positive, negative. So negative. So we put a negative sign on top of that interval. So the order of signs from left to right is negative, positive, negative. So what does the sign chart tell you? It tells you at a glance what the sign of the function is on those subintervals. So that means the function here, f of x, which we denoted by f a while ago, is negative throughout the interval negative infinity, negative 2. And similarly, positive throughout negative 2, 1, negative throughout 1, infinity. Now, by the way, you have to put on top of the critical numbers themselves the value of the function, where the function is either 0, right, or not defined. If it's 0 at those critical numbers or at a critical number, put 0 on top of that critical number. If it's not defined on that critical number, put ND for not defined. Sometimes we can put a hollow circle to indicate that it's not defined there, or just put an ND on top. And sometimes we can use a solid circle to indicate that it is 0 there, as I will show in the next example. Unless there's a question, anyone? Just send a message in the chat box or just unmute your microphone and ask permission to speak. Okay, no question. So let's have one more illustration before a seat work. Okay, by the way, I forgot. So we are to solve the inequality now. So what does the inequality require? It requires that the function whose sign chart is this be greater than 0, strictly greater than 0. So that means the critical numbers, negative 2 and 1, are not part of the solution. So it will be an open interval. So our solution set is the middle interval here, because there we have a positive sign. It says here it must be strictly positive. So the solution set is the open interval negative 2, 1. Always write your answer in solution set form, not set notation form, okay? Or set notation. Now, sometimes the inequalities that you will encounter are rational inequalities, meaning denominators are present in the inequality. Like in this one, there's a factor x minus 1 in the denominator. So the inequality is called a rational inequality because this one is a rational function. What is a rational function, by the way? In algebra, Remember, what is a rational number? It's a ratio of two integers. Yes, let's see. Okay, ratio of two polynomials. Good. So if a rational number is a ratio of two integers, a rational function is a ratio of two polynomials. You know what a polynomial is? So I will assume that for now, though we will also be defining polynomial functions in a later chapter. But this one is a rational function because it's a ratio of two polynomials, a quadratic polynomial and a linear polynomial. So it's a rational inequality. Now, as usual, we first construct a sign chart for the function before we solve the inequality. Here's the sign chart. Now let me explain again how I got that sign chart. So first, what do? Find the critical numbers. Now this time, since we have a denominator, we have to equate the denominator as well. And it will give you the critical number 1 here. You see that? It's there. Now I put a hollow circle to indicate that it's not defined at 1. Or you may just want to put an ND on top of that. And the other critical numbers are 2 and 4. They came from the numerator. So they will make the function 0 in value. So I use solid circles to indicate that. Or you can just put 0 on top, which I prefer. When we go to the sheet work, that's what I will be doing. Instead of using hollow and solid circles to denote where it is 0 and where it is undefined, we'll just be putting 0 or ND on top of the critical numbers. So there are 3 critical numbers. 1, and from left to right, -2 from this factor, 1 from this factor, and 4 from this factor. So 3 in all. So they will divide the real line into 4 subintervals. So again, solid point indicates the function is 0 at -2 and 1. Hollow point indicates it is undefined at 1. Now, why is the solution set -infinity 2? Okay, closed at 2, union 1, 4, open at 1, closed at 4. Well, after you have determined the signs by using or choosing test numbers for each subinterval, you will have the following order of signs from left to right: negative, positive, negative, positive. Now just verify. I won't be doing it here. I will just be giving you a sheet work anyway. So just verify that this is the correct order of signs. Now, once you have determined the order of signs, you are ready to solve the inequality. What does the inequality require? Less than or equal to 0. So that means either it's negative in value or 0 in value. That means we will include the critical numbers where the function has 0 value. Namely, -2 and +4. 1 is not part of the solution because it's not defined there. It's not in the domain. The function is not defined there. So here's our solution set. Those where we have negative signs, -infinity to -2, including -2. Sorry, this should be -2. And also this interval here from 1 to 4, not including 1, excluding 1, including 4. So parenthesis for open, meaning that endpoint is not included, and then bracket, or what they call this, brace, for denoting that it's part of the solution or the interval. So you use the union symbol to put in all the possible solutions. So is there any question? Okay, if there's none, let me give you 5 or 10 minutes to solve the following inequality. Now, in the modules or handouts, there are practice exercises as I have mentioned a while ago, and they are the following. You can find these practice exercises in the module 1. So do it for later or if you have free time. So as it works, solve this inequality. Take note, there's a square for this factor, so it will always be positive. And there will be 3 critical numbers. And please be careful with the sense of the inequality. It's less than or equal to 0. You might find the equal sign there tricky when you write down the solution set. Okay, if you have questions, now's the time to ask. Otherwise, just continue doing the problem. Okay, if you have an answer, can you please send it in the chat box so I can see if some of you at least understood the topic. Okay, that's partially correct. Okay, there, that's correct, but your set notation is wrong. Okay, so I'll just show you the sign chart. There. You should have plus, plus, minus, plus. Critical numbers, -5, -3, 7/2. Now, the sense of the inequality is less than or equal to. That means you have to include the zeros. And since 5 is isolated from the interval here, you have to indicate that it's part of the solution using set notation. So you have to use braces. I'm not sure if this is called braces or brackets. Parang brackets yata, no? So you have to use this one to denote that it's the set containing the point -5. And of course, the semi-open interval here. Open at -3, because it's not defined there, it's ND. If you plug in -3, it will become, the denominator will become 0. You cannot divide by 0. So it can never be part of any solution of any inequality. And you have to include 7/2 as well, because the function is 0 there. So it should be closed at 7/2. Okay. Is there any question still? Okay, good. So that's it for today. I already, by the way, posted the link where you can buy the ebook. Unless you have question, you are free to go. So that's it. I'll be ending the class.